All right, good afternoon. This is Dr. Doucher recording um, the lecture for today. And so this is August 24th, 2020. This is our second lecture in SYS101 Introduction to Systems for the fall of 2020. And unfortunately, I neglected to bring the recording equipment to class today. And so I'm doing this to at least give you a little bit of recorded lecture to go along with your notes. So we're going to talk about modeling and modeling systems and their processes and functions and all that good stuff. And so, first, what is a model? Why do we need a model? And so, a model is basically depending upon how we're doing things. It can be a schematic description of something. You could even be, in the line of work that I do primarily, I build scaled models, three-dimensional scaled models. And so it allows us to look at how things work together, characteristics of something, interactions, interfacing, and so forth and so on. And so these are all things that are done easily with a model. All right, and so one of the things that we've probably all seen before is some type of math formula. And so here we've got E equals mc squared as a conversion of mass to energy. This is one of Einstein's great things. So the formula in and of itself is simple and elegant, and but when we get more into the calculating out of a series of formula, it gets a little bit more messy. All right, and so what again, the whole concept here is to be able to take something that's very complex and wrap it up in a nutshell and allow us to communicate that information to someone else. And as I've said in lecture, this is kind of a universal language. You don't even need to speak the same language to be able to share ideas and how things interact and so forth. All right, so primarily we're going to be using diagrams to depict our models, and so depending upon what it is that we're trying to do, we'll use different types of diagrams, different types of modelings. And so the one that we're going to talk about today is the context diagram. And as we go through the semester, we're going to work on several different other types of diagrams and models to depict information and to show various things, from characteristics of something to relationships, even to the flow of information or the flow of a consumable through a process. All right. Let's see. So, again, models allow us to take something fairly complex and communicate it. And as I said in class, almost all of this that we're doing can be scaled. And when I say be scaled, meaning that I can step out and I can look at the system, and we'll start with the context diagram, which I'll cover later on in this lecture. I can look at it as an overall system and its environment, okay, and I can set boundaries, and I can look at what are the influencers of those within that boundary. All right, so the second point here, models allow easy manipulation of concepts before committing resources to build it. And so this works in a lot of different ways. We can make changes, simple changes, even complex changes with a model and get an idea of how that might interact, the ripple effect of changing one thing throughout a system. And before we spend a lot of money. And so, on the other side of that equation, again, as I said in the very first lecture, I'm more of an industry type systems person rather than a computer type systems person. And, when I work in metals, and to do work in metals is quite costly. And so whenever I'm trying something new, I actually will develop a model of what I'm trying to do out of much less expensive materials, and I use the concept of rapid prototyping and iterative design to arrive at a functional working model that I can hold in my hands, and I can see how things work and how they interface and interact. But it's the same thing with using diagrams. We can make small changes and we can visualize what the reactions are from that. All right, the last little bit there, using models and diagrams, we can all be on the same sheet of music within our team and with our stakeholders. And as I said in class, a lot of times our stakeholders are not technical people, and so how do you communicate very technical information to non-technical people? Well, through the use of diagrams and models. All right. So when we're doing our diagramming, and again, we'll have, I think, 4 different diagram methodologies that we're going to use. There is a particular format that we want to follow, and so as we go through these, this slide will come true, and you're going to see that the words that we use matter. And so, on some things we're going to use action verbs. Others we're going to use adjectives. All right. Shapes mean different things. Colors can mean different things, and lines can mean different things, depending upon which model that we're using. And so this slide is just kind of a heads up to you that as we are going through this, it's not haphazard. All right, as we get into the context diagram, the system itself is a circle. It's enclosed within a circle, and then we have boxes, rectangular boxes set up for the influencers within the environment of that, and then we have lined arrows that are the inputs into the system, and then the outputs out of the system. So it's not haphazard. And so as you're doing the diagrams, you're doing the homework, please make sure that you use the appropriate verbiage, the appropriate line types, the appropriate shapes, colors, and etc., because it does matter. Later on in the systems curriculum, they'll do some fairly complex math models in SYS101 and 402. But that doesn't really have a whole lot for us as of right now. Just know that we're going to take this same concept and carry it on through for further refinement as the systems curriculum continues. So these are some of the things that we will actually model. All right, and so processes or functions, as I said in the initial class, that the basic definition of a system is that you have some type of input that goes into the system, some kinds of processes happen, or otherwise known as functions, and then the input was changed in some way and then is now an output. All right, and so models allow us to depict that, to graphically depict that, so that people can understand what actually happens within a system or even a subsystem And again, in lecture, that's one of the key tenets that I talked about, was that um, we could start at any point in time and we can establish the scope of what it is that we're looking for, or looking at, I should say, and we can drill down or we can back out to encompass as much of the system or as little of the system as we want in order to um, examine the things that are going on in there. And the things that do happen are processes, interactions, and interactions are within the system, subsystem. There are different components, different things that do things, and so we're seeing those interactions. As we get towards the latter part of the semester, we'll talk about data and the storage of data, and more importantly, the retrieval of data. And so we'll use the SQL system, the SQL language, to find data that would be otherwise difficult to find. All right, and then we'll also look at the flow of goods or services or even money through a system, through subsystems, processes, and so forth. And so, again, when we start this process, it's a good idea to start first with this thing that we're going to talk about next, is the context diagram. All right, I threw this slide up in class, and this was actually presented in a briefing when I was getting ready to go over to Afghanistan in 2009 during Operation Enduring Freedom, OEF 9 and OEF 10. And this is not what we want, okay? This is really convoluted. This isn't really actually communicating anything. But I will say that that they make use of different colors of lines, and you can see even up at the top, you got the little bar that shows a significant delay. There's a rhyme and a reason to how this is done. All right, this is not a diagram that I would ever use to try and explain something to someone, okay, because it's still too complicated. It's much too complicated. There's much too much going on. There's better ways to do this, but I do want you to take a look at that there is a method to the madness on this, and that if a person took the time to really work it through, there's a lot of information. I mean, there's a bunch of information that can be transmitted through this, but yeah, this in and of itself is too much, and so there's better ways to communicate this information. All right, as I outlined in class, this is a slide that you are going to see throughout the class. All right, and you will see it on every single exam that you have, and so you need to memorize this. All right, and so we're starting here. We're looking at when we see over on the far left-hand side there, the system. All right, and so how do we look at the system as a whole? Well, we use what's called the context diagram. All right, which establishes the scope of the system and the influencers of that system, how those things interact within the environment. All right, so the next one will be the cross-functional process map, otherwise known as the swim lane diagram, which shows the flow of work through a system, and so it identifies different functions and things that happen within those functions. And functions departments are interdependent words for the same thing. All right, the flow chart, and so the flow chart, basically shows the flow of something through a process. And so the key thing that delineates a flow chart from everything else is that we'll have decision points. You can show delays in there. and so forth. And then the final one that we'll talk about in not a great deal of detail is the state diagram. And I just want you to understand the state diagram concept. And so in class I talked about, if I brought in a table lamp from home and I set it on the tables there in the middle and it's unplugged, it has a state. All right, and if I plugged it in, I would know that the state is either it's off or on. All right, and the state diagram also shows the progress to go from one state to another, and there can be multiple states. It doesn't necessarily have to be just on or off or whatever. It could be low, high, or low, medium, high, off, or there's a lot of different things. This is more of an industrial concept and has a little bit more application in the industrial side of it. So we'll talk about it, but we're not going to do a whole lot with it. I just want you to understand the concept of it, and that'll do us. All right, let's see here. Okay, so here we go. The purpose of a context diagram. So the very first thing when we're breaking down a system, we're going to study a system, we're going to try to learn something about it, is that we need to understand the scope of that system. All right, and so what we're looking at is the environment. All right, so we're going to take that system as a whole, and again, I could do the same thing if I went within a system and I picked out a subsystem of something. I could do the exact same thing. All right, but for right now, we're just talking about, we'll take the whole system as a whole, and then we're going to look at the things that influence that system, and that's called the environment. All right, and so those things that influence the system are things that feed into the system. So if we had a restaurant, inputs into the system for a restaurant would be, hey, we've got raw materials, raw food is brought in. Customers come in bringing cash. You got the bank is inputting different things. What do we have as far as outputs? Well, obviously we're going to have food as an output. We're going to have waste as an output. Money is going to go from the restaurant to the bank. That's an output. But basically it allows us to get an idea of the stakeholders in that, and the different things that interact that feed into that particular system. And I used the term stakeholders earlier, and so again, those are people or other entities that are in that environment, and so they might be an input or they might be an output. And so a stakeholder for a restaurant, obviously the customer is going to be one of the biggest ones. All right, but there are other stakeholders that are involved in that. All right, let's see. And so as I just said, I kind of alluded to this earlier in that we're going to start with you typically are going to start with this type of approach, in that we get an idea of the scope of the actual system that we're going to be studying, and again we can step into a system and look at a subsystem and do the exact same thing. And so this helps identify early on what it is exactly that we're studying, and so that as a group, with yourself, your team members, your customer, you're identifying what it is particularly that you're studying. All right, let's see. So here is the nomenclature, I'm having a moment. Anyhow, this is, I talked earlier on, on a slide about how things are represented, how there's a set way. All right, this is it. So for when we're talking about a context diagram, the system in itself is going to be enclosed within a circle. All right, and now you'll notice that in this particular one, it's system name. All right, generic as can be. All right, but there's no breakdown within that. There's no subsystems. There's no processes. There's no functions. There's none of that stuff going on, because that's outside the scope of what we're looking at here. But what we do have we have external entities, which are things that are either give an input or receive an output from our system. Again, these are our stakeholders for this particular system. All right, and so these external entities are enclosed in a rectangle. All right, and then those inputs and outputs are shown with an arrowed line. All right, and again, this last little block does not show functions or processes. Again, we're just looking at the system as a whole, and we're examining the environment that that it lives in. All right, and then we talked a little bit about this particular context diagram of the bookstore. And so, the bookstore itself is surrounded by the circle. We have the external things in rectangles, and then we have the arrowed line showing the inputs, and then the arrowed line showing the outputs, again, to external entities, things that exist within the environment of that particular system. All right, and so I did give a homework assignment, which I believe I set due for the following Saturday at 11 p.m., which would be to go in and do a context diagram for a restaurant. And I don't particularly care what restaurant that you want to do, but look at what is the environment that it lives in, what are the boundaries, and then what are those external entities, what are the inputs, what are the outputs. All right, and try to be imaginative and come up with things that other people are not coming up with. All right, so that is our lecture in a nutshell for the day. As always, I hope this was helpful, and Doc D out.